we're looking at 1.3, understanding the limit, and what we're going to be going to is if I just give you a function, can you find the limit? So what we have is we have this function, which is also graphed over here, and you can confirm that this is the same as this with the graphing calculator. But if we just look at f of a, we're going to assume a is this value. Well, if we asked you to plug 0 into this function, well, anything times 0 is 0, plus 4 is 4. Half of 4 is 2, minus 4 will give you negative 2. So as we look at this from the graph, well, at x equals 0 is right here. I'm just going to put a hole right here. If you recall, the limit from the left side needs to equal the limit from the right side, and they do. They equal the same thing, and it equals negative 2. So if we do the same thing with x is approaching 2 from the right side, well, if we look at 2 is right here, and man, I should change colors for you. 2 is right here, and it's asking for the right side, so we actually only care about this side, and graphically I think that's pretty clear that it's approaching negative 4. And as we plug in 2, well, if you double, so negative 2 times 2 is negative 4, plus 4 is 0, absolute value is still 0, half of 0 is still 0, minus 4 is negative 4. And I know they don't give you on the graph for 10, but if you continued on and looked at the graph over here at x is 10, if it kept going, you would see that, okay, so this is 6, 0, it would be 7, 1, going so on and so forth, 8, 2, 9, 3. It is 4, and you can believe me. But otherwise, you can look at this and say, okay, well, negative 2 times 10 is negative 20, plus 4 is negative 16, absolute value is positive 16, half of that is 8, minus 4 is 4. And what you should notice is all of these are equal. So your question might be, is that always going to be the case? Well, as long as the function is defined and continuous. Because if you recall from a previous lesson, we could have holes, we can have asymptotes, we can have things that kind of break up. But if it's defined and continuous, then you can find the limit as x approaches a of f of x by just finding what f of a is. That's an equal sign. So we sometimes use the phrase direct substitution. As long as the function is, sorry, it went off the screen. As long as it's defined and continuous, you can just plug in a in for x to find the limit. So a few of the problems are very straightforward. All you need to do is well, you need to know that polynomials, this is a polynomial, is continuous everywhere. So all you have to do is substitute 3 in for all your x's. And this is a correct answer. So 3 squared is 9, 1/3 of that is 3, minus 6 is negative 3, plus 3 would be 0. I'm glad I went back and double checked that. Let me fix that. That says 1/2. Why is it so large? See if that fixes it. Okay, 1/2. Oh, I made it too small. There we go. So this is 9/2 minus 6 plus 3 is equal to 3/2. There we go. Same thing with this next one. Just trying to change colors. Is as long as you can plug in 3 in for both these x's. So 5 times 3 plus 2 all over 2 times 3 minus 3. So 15 plus 2 is 17, and 6 minus 3 is 3, then you should be good. This should be your limit. And it is continuous, because the only place this is not continuous is at x equals 3/2, which we talked about in pre-calculus. Oops, I scrolled down too far. So moving on, again, maybe I should point out slightly different that x is only undefined in this problem should probably be careful on how I say this. Because, so x cannot be -1 because of the denominator, but we also want to be careful with the square root. We can only square root positive numbers. Well, if you put 2 in for this problem, well, 2 plus 2 is 4. We can square root that. So square root of 4 minus 1 over 2 plus 1 is 3. So what we're looking at is square root of 4 is 2 minus 1 is 1. So that is okay. This is defined and continuous on that problem. Now this next one, I really hope that you spent some time over the summer practicing your trig stuff, and you can plug in pi over 2 in for theta. And what you'll notice is the 2's cancel there, so just sine of pi, well, on the unit circle, pi is over here, and that's the ordered pair -1, 0, and the sine is always the y-coordinate, so sine of pi is 0. It's the sine function is continuous there, so we're good. Same thing in the next one. Cosine is continuous everywhere. We're dividing by 2 pi over 3, so that's not an issue. Just change colors again. So think about where 2 pi over 3 is. And it is up here. That's the ordered pair -1/2. It's the x-coordinate, which is what we're asking for cosine, over 2 pi over 3, because I'm doing direct substitution into the denominator. Well, to divide by a fraction is the same as multiplying by the reciprocal, so 3 over 2 pi. So we're looking at -3 over 4 pi for that answer. And then same thing with the next one is we can plug in. The only thing we need to make sure is that we can log positive numbers. And if I plug in 9 right there, 11 minus 9 is 2. So we're looking at log base 8 of 2. And for the sake of ease, I would say it's okay to just use your calculator right now. Otherwise, you could do the change of base formula. Like, I guess what I'm saying is 8 to what power gives you 2. And we spent a lot of time doing this in pre-calculus. And what you can do is get the same base. So 2 cubed is equal to 8. 2 to the first power. And then set up an equation. So that question mark that I wrote down, I'm not sure what just happened there, is equal to 1/3. So this answer is 1/3 on that. All right. But here's the thing, is not everything is that simple. Because if I were to try to plug in 3 in for all of these x's, again, 3 squared is 9, sorry, -3, but it is 9, minus 12 plus 3, you get 0 on top. And if I plug in on bottom, -3 squared is still 9, minus 6 is 3, minus 3, you get 0. Well, what's the answer now? Question mark. Because somebody might say, well, 0 divided by anything is 0. Well, can you even divide by 0? That's undefined. Anything divided by itself is 1. So there's 3 different reasonable answers here for this answer. Same thing with this one. If I were to plug in 1 into all these problems, 1 plus 4 is 5, 6, 7, 8 on top, and 1 plus 2 is 3, minus 3 is 0 on bottom. Okay, I need to put arrows because it's not correct. Because what happens when you divide by 0? That's undefined. And then same thing with this one. I think it's a slightly, well, the only difference between this one and this one is this from the left side and from the right side. So we still get 8 divided by 0. So direct substitution now does not work. This is does not work. And I could even ask you to factor these problems. Let me switch colors and factor. If you were to factor the numerator, factors of 3 that had to be 4, 3 and 1. Well, if I look at the denominator, what are factors of negative 3 that add to be 2? You would say x plus 3 and then x minus 1. And what you would also hopefully notice is these are canceling factors. Well, as we look at what the graph of this actually looks like, well, if we look at the whole right here, we should have had a limit from the left and the right that equals a number. So we should have, when it was 0 over 0 up here, we should have had a limit. And that answer was 1/2, not even one of the options that I mentioned earlier. I said 0 or undefined, or I said 1. The correct answer was 1/2. And same thing with this one. When I had 8 divided by 0, on the left side, it's getting closer and closer to negative infinity. Now, I know I mentioned does not exist, and that is true, but you could state the behavior. And same thing with the right side, is positive infinity. Again, the does not exist still holds true. And the difference between these is what kind of factors did we have? Well, when we had a canceling factor, it created a hole in the graph. You know, that 0 over 0 created a hole in the graph. So it does have a limit. And that's exactly what we need to talk about here. So analytically, if we have a canceling factor, we need to do that. Creates a hole. So the limit does exist. Now the non-canceling factor in the denominator is a vertical asymptote. So there's a little bit more work to be done there. Now let me actually get to that point. And then I'll pause the video and finish this. Is if we were to rewrite this problem. Now here's the thing about calculus, is equality needs to stay true throughout. So what you need to do is make sure that you write limit over and over again until you actually do the substitution. So I'm going to be a stickler with that. Make sure you do that. So notice all I'm doing is I'm factoring, and you have to rewrite the limit. And if you factor the denominator, I already did this earlier, that's why I'm not repeating myself. You can cancel out the x plus 3's. And now what you should notice is this negative 3 when I substitute in for both of my x's. Well, negative 3 plus 1, notice I'm not going to write limit now. Negative 3 plus 1 is negative 2. And negative 3 minus 1 is negative 4. Well, what's negative over negative? Positive. 2/4 reduces to 1/2. The answer that we promised that it would be earlier. Right there. So that's how you can use a cancellation process in order to find the limit analytically. And just one more thing before I pause the video and upload a new one, is in pre-calculus we learned that premise that a non-removable infinite discontinuity creates a vertical asymptote. And since the y values do not approach one specific from both sides of that vertical asymptote, we have a little bit more work to be done. So we could do all the same work, and we showed this work earlier, but I'm running low down to a minute in this video. But if you're doing the left side of x equals 1, choose a value that's to the left of x equals 1. Now don't actually do the math, just look at it. And if you say, okay, well 0.9 plus 1, that'll give me a positive number. And 0.9 minus 1 gives me a negative number. Well, what do you get when you have a positive over negative? You get a negative, and because we know it's a vertical asymptote, it's either negative infinity or positive infinity, so this answer on the left side will be negative infinity. So then on the right side, pick a number to the right of x equals 1. And again, don't actually figure out what the number is. Just say, well, 1.1 plus 1 will give me a positive. 1.1 minus 1 will give me a positive. A positive over a positive is positive. So this answer is positive infinity. And I'm going to stop, upload, and create a new video to finish these notes.